We made it. Finally. Months of work. And we're here. A working CNC that does acrylic, wood, and aluminum. It works. I am stoked. So the first question you're probably asking is why? Why build a CNC machine? There's plenty of them out there available to buy, so why build one? The biggest reason I wanted to was a learning experience. I saw that it was possible to do it online. I've done lots of 3D printing and designing and everything like that, so I wanted to take my engineering skills to the next level and try to produce something. So let's briefly talk about what a CNC machine is. So CNC stands for Computer Numeric Control. So basically what that means is I have a little microcontroller that tells a motor to move a small amount. With the computer being able to tell the motor to move a very small amount, it can do it in a repeated fashion, meaning that it can rerun the same job and produce the same results every time. When it comes to a CNC machine, the primary thing is going to be rigidity and power, and rigidity by far being the most important. The rigidity of the machine means that when the bit is going through and it's doing a cut on a piece of material, the bit isn't going to be shaking or moving at all. The more that the bit moves or shakes, the more chatter and the more likeliness that you're going to break a bit. Now, going into this build, I knew I was going to be doing 3D printing. So I'm using plastic parts, which is already kind of a negative as far as rigidity for a CNC machine. So this is all done with PLA since it's the most rigid of the plastics, but it also makes it very brittle. If it starts to break, it kind of shatters. In order to increase the rigidity of the PLA prints, they're all 50% infill and 5 layers of depth. So each one of these parts is hefty and has a fair amount of cost as far as the filament that goes into them. A big requirement that I wanted to put on this was to reduce the amount of cutting as much as possible. Going into this, I didn't have any tools at all. So the only heavy machinery that I really used was a miter saw and a drill press. And even the drill press isn't necessarily required. So this is done with very little tools. Obviously a 3D printer to do the 3D printing, but otherwise everything else is just standard Allen wrenches and screwdrivers and such. I had a number of goals going into this build. The first one being that I wanted to keep it around $1,000 mark, which I did not hit. The other was that I wanted to create just a generic 3-axis CNC machine. It's kind of the most common CNC machine. There's a bunch of different variations, and adding the rotary ones, so 3+1, along with 4, 5, 6-axis ones, which get intensely complicated. I wanted to get a roughly 1,000 by 250 millimeter area of working area. So basically it can fit on a 4-foot by 2-foot table. I also wanted to make sure that all of the 3D parts could be printed on a fairly standard 200 millimeter cubed bed. So pretty much any 3D printer is going to be able to print the parts that are necessary. For the hardware on this, I ended up going with a Makita router. It's fairly cheap as far as CNC routers. It's not using a full-blown spindle. That kept the cost down. One of the main targets I wanted with this was to keep it around $1,000 mark, which I definitely did not hit, but it wasn't crazy expensive either. A machine that is capable of what I've made is probably going to cost twice as much, though I've spent hours and months of time developing this. So as far as hourly rate, probably not worth it. One of the early requirements that I ended up doing was going away from the idea of using belts. It would have made the build dramatically cheaper by several $100s, but I was looking a little more for the consistency and using the lead screws to help improve the stability of the system. So I'm happy that I went that way, but it definitely could have been done cheaper. There are a lot of modifications that I'd like to make to this machine. One of the biggest one being a dust boot in order to collect a bunch of the dust and materials, the chip load that actually comes out. I'd also like to add lighting along with some compressed air and a camera. One of the additional ones that I added after this build was done was actually a limit switch for the Z-axis. It was one I kind of overlooked, which I didn't think was necessarily required because you kind of have to probe down to your material all the time anyway to get to where you want it to be. But it turned out in order to kind of zero out the machine, it was kind of a necessary one. So I ended up doing some modification to the head of the Z-axis and added in a limit switch. For the electronics, I ended up using a ESP32 dev kit with wireless and installed Fluid NC on it. So that was a fantastic choice. I absolutely loved everything about Fluid NC. It took a little bit to get up to speed on it. Going into this, I knew nothing about CNC process, like the CAM workflow or generating G code or any of that, other than what I've done from just 3D printing. But going into this, I definitely learned that the CNC process is drastically different than the 3D printing process. You don't really have to think about speeds and feeds with 3D printing, where you definitely do when you're starting to use bits and cutting into material. So I was able to successfully cut acrylic and wood and aluminum. The aluminum side of it I have to go a little bit slower. The machine's not quite as rigid as I would like, though I may be able to improve that with a few modifications to the design, specifically around the gantry where it's holding everything together. Everything was designed in Fusion 360. Including the test cuts and the CAM software, all through Fusion 360. There's definitely a lot of things that I'd like to change for the design going into a Mark II. If you'd like to see those designs, I'd encourage you to like and subscribe, follow along, keep up with me, because I've got a lot of stuff planned for it. Another important choice that I made was no steel parts. So I'm a web dev by trade, and so I don't have a whole lot of experience doing big cuts or heavy machinery kind of things. I didn't want to have to go finding a local place to help cut steel in the right dimensions that I needed and everything. So I wanted to keep this wood just aluminum for this one, and then kind of adapt after that. And with the way that this is being developed, I'll actually be able to use the CNC machine to build its own parts out of aluminum. So I can slowly upgrade it, that I could then potentially even mill out steel once I've fully upgraded the aluminum. So all in all, the entire build was roughly $1,500. It was actually closer to $2,000 that I spent, but there's a handful of things that weren't actually used in extra parts and stuff like that. So the actual parts and value that went into it was about $1,500. That required a lot of iteration on the plastic, the filament specifically. I went through a lot of filament, like iteration after iteration after iteration. All right, if you like what you see, I'd like you to follow along, subscribe. I have a Discord, if you can find that in the description below. Love to hear what you have to say and see any of the projects that you guys are working on. Catch you in the next one.